So this is going on page 40. So we've added, subtracted, multiplied, and divided these. And now we are going to compose them. This is a review from Algebra 2 as well. One thing that y'all did not do in Algebra 2 when you do composition of functions is you didn't look at the domain. So we're going to look at some domain restrictions, and that's what just adds a little bit to this. Okay? But then we're going to apply this in some of the stuff that we're doing next week. So composition of functions. It says another method to combine functions besides the add, subtract, multiply, and divide is called composition. So given f of x and g of x, the composite function f of g of x is defined as, so it can be f of g of x. It kind of looks like fog, but that's not an O. But it's also not a dot, because when we did multiplication, it was a dot. Right? So not a dot there. So f of g of x equals, another way to write it is f of g of x. I actually prefer that way. That's showing that you're taking g of x and substituting it into f of x, right? So that's just like if we had f of 4. This could be f of 4, which would mean that we substitute 4 in everywhere we see an x. F of g of x means you take g of x and you substitute it into f everywhere you see an x. And that's how the functions get kind of intertwined. So again, the domain is the new part of this. And this wording can be confusing, and you have to talk your way through it every time. So every time we do it, I'm going to talk about this is what it is because it can get confusing. It says the domain of the composite function, f of g of x, is the domain of g such that g of x is in the domain of f. Okay, so I know that's just like wordy mess, right? So let's think about what that says. The domain of g, when you're talking about the domain of something, are we talking about x values or y values? X values. Okay, so the x values. Such that g of x, would that represent x values or y values? Y values is in the domain of f. So again, we're talking about x values. So here's what happens. We have values. We have x values. We substitute them into g. So they're my inputs. Substitute them into g. I get some y's out, so I get some outputs out of g, right? Those outputs now become the inputs into f, right? So we get input, output, and then input again, right? You put your clothes in the washing machine, they're dry. The output is wet clothes. You take the wet clothes and you put them into the dryer, and then the dryer dries your clothes, right? So it's like a two-step process. That's what's happening here. You got an input and an output. That output now becomes the input into the next part. All right, and I know that can get confusing. I mean, I have to talk myself through it every time, and once we do some examples, it might make a little bit more sense, but you have to kind of talk your way through what's happening, okay? It's not that bad. Just sometimes the wording is confusing on things. So let's look at example 1. It says we're given f of x and g of x. Find each function and state its domain. So we have to talk about the function before we start, and then also the composite functions. So when I graph this, what is this going to graph as? What's this parent function? It's a linear, right? So what's the domain then? All real numbers. What is this graph as? Quadratic, and it's all real numbers, right? So those are easy, right? We good so far? Okay, so now we need to find f of g of x. So this means f of g of x. So this is f of, well, g of x is x squared minus 4. So I need to find f of x squared minus 4. You with me? So I take x squared minus 4, and everywhere I see an x over here, I substitute it in. So that's equal to x squared minus 4 plus 7. Everybody okay with where everything came from? Ask me a question if you're not sure what happened. You got to speak up. Okay. What happened to the x in the f of x? Okay, so just like if I'm going to evaluate f of 4, f of x equals whatever, right? Well, let's just say this. F of x equals x plus 7. But I want to find f of 4, and then I substitute in the 4, right? So I want f of g of x. Another way to write it is this, right? So it's not f of x. This is my input. X isn't the input, it's g of x. So that's where that comes from right there. Does that help you? Does that make sense? Okay, are we good with that then? Okay. And then can I simplify this any? Are those parentheses really doing anything? No, but it's good when you substitute something in that's more than one term, put parentheses around it, because when it does matter, they need to be there. And if they don't matter, then whatever, you just lose them and you're fine. And so that means this gives me x squared plus 3. So f of g of x is equal to x squared plus 3. Okay, but I also have to state my domain. So the domain is the domain of the input, right? My input is g, right? It's the domain of g as long as the outputs live in this domain. So let's think about this. The domain here is all real numbers. The outputs is the range, right? What are your outputs all real numbers on this? No, what would they be? Is it even? Of the parent, good. Of the parent function is 0 to infinity, right? What happens to the parent function here when we graph it? It goes down 4. So instead of from 0 to infinity, we're at -4 to infinity, right? So my outputs that I get, the wet clothes I take out of the washer, they are going to be from -4 to infinity, right? Now, that doesn't mean that this is the domain. What that wording says is, this is the domain as long as my outputs, which are from -4 to infinity, are part of this domain. Does -4 to infinity live in all real numbers? Like, it's not the same thing, but any number I get from -4 to infinity, is it part of the all real numbers set? Yes. So then I'm good, right? So here's the thing, is when they're both all real numbers, your domain is all real numbers. But I wanted to talk you through when it works like that, because that's how you have to look at the output, and then is it part of that next domain? Okay, you with me on that? I know that's a little confusing at first, but it gets a little bit better. So my domain is all real numbers. Okay. So now we're going to find g of f of x. So g of f of x. So now my input is f of x, which is x plus 7. Right? So when I substitute that in, I'm going to get x plus 7 squared minus 4. Everybody good so far? Now, are you capable of squaring that binomial? Is it x squared plus 49? No. No. It's not x squared plus 49. We all know that, right? Okay. But you know what else? I don't even care what it is. Because one of the things we're going to be doing with some of these is graphing them. And if I need to go graph it, do you like it in this form to graph it? Yeah, because then I can see my transformations, right? So right there, I'm good. And this is g of f of x. Okay. Now I've got to look at the domain. All right, so the domain is the domain of the input, which is f, all real numbers, as long as all the f of x values are in here. Well, this is a line, right? Your domain's all real numbers. What's your range of a line? All real numbers. So does all real numbers live in all real numbers? Yes. So it's all real numbers. And again, if they start off both being all real numbers, every time for the composition, it'll be all real numbers. Okay, we'll look at some where it's not going to work all that way. But okay, we all good so far? All right. So now let's look at g of f of x. We're going to do example 2. We're not going to do all of it. But we need to, oh, goodness, it's jumping. All right, so let's look at these domains first of all. This is a what if I graph it? It's a linear, so that means it's all real numbers, right? This is a, yeah, it's actually a rational. It's not even, you know how y'all were trying to want to say rational? It's a rational. It's not just a reciprocal, but that's okay. It doesn't really matter. What matters here is that we can figure out the domain, right? So when you graph rationals, do you know what's going on with your domain here? Okay. Is it all real numbers? No. What? Well, what can't be 0? The denominator. We can't divide by 0, right? So this can't be 0. So if x plus 1 cannot equal 0, what can't x be? -1. So it's the set of all x's such that x can't be -1, right? Go ahead. Yes. Yes, exactly. Did y'all hear his question? If this was the reciprocal of this and we had x plus 1 over x, then you always use the denominator because it's just whatever the denominator is can't be 0. So then it would be x can't equal 0. Yes, good job. Anything else? And it's not just a straight up reciprocal because I have a variable in the numerator also. That's why it's not that. All right, so let's look at this. We're just going to do b. So I want g of f of x. And so this is g of 3 minus x. So I get the numerator is just x, so that becomes 3 minus x, over the denominator is 3 minus x plus 1. So I substituted those in for the x's. You with me? Are my parentheses really doing anything anywhere? No, they're really not. So I can just drop them in the numerator, and I get 3 minus x over, what does the denominator become? 4 minus x. Yeah, don't make it harder than it is. It's just 4 minus x. Everybody okay with that? Can I simplify that any? Can I cancel the x's out? No. It's got what? Got glue on it. Who told you that? What's the glue? Okay. Oh. Woo! So is the glue the minus sign? I got to ask her. That's a good way to say it. Okay, good. Because sometimes you can cancel things out, right? But that's only if it's one. It's when you have more than one term. It's got glue on it. I like that. Okay, good. So that's equal to, I got to go ask her what else she says because I got to steal that. All right, g of f of x. So that's it. But now I got to look at the domain. So here's where we talk about it again. It's always the domain of the input. The input is f, all right? So it's the domain of f as long as all of the f of x values live in this domain. All right, well, this is a line. My domain is all real numbers. My range is all real numbers, right? Does all real numbers live in this domain? No, right? But here's the catch. It's not just that it can't equal -1. I really don't care about that. What can't equal -1 is actually f of x. Because remember, your f of x becomes your input. See? F of x is my input, right? So it's not that x can't equal -1. F of x cannot equal -1. Okay? So think about that for a second, because I know that seems a little weird at first. It's your input. Your input cannot equal -1. F of x becomes my input. Well, this is f of x, right? So that means that 3 minus x cannot equal -1. Everybody with me? So now I can subtract 3 from both sides, and I get negative x cannot equal -4, which means x can't equal what? 4. Okay? That's the domain I use. We okay with that? Okay. So I come over here, and my domain then is the set of all x's such that x cannot equal 4. And if you look here, I mean, you can get that from the final product too, right? But sometimes things cancel out where you don't see all of those restrictions in your final product when things cancel. Okay? Are we all good with all that? Any questions so far? Okay. All right. So let's, okay. Yes. Yes. Okay, so we have the, did y'all get that? Like I can tell you like he got it, but okay. So we find the original domains. So to find any restrictions we might have, we have to use whatever's here. Like since x can't equal -1, that's when x is your input, right? X is no longer my input. F of x is my input. So it's the input can't equal -1. The input can't equal -1 because I've changed what my input is. You with me on that? Okay, so that's, and again, I know that can get tricky with your wording, but any questions about that? Sometimes this is one of those things where it has to like soak in for a minute and then we have to revisit. Go ahead. Yes, that's why it's always it's this It's this domain as long as this range fits in there. Yes. Okay, so it's the second one. That's why I pointed to it every time. It's the input that you're looking at there. Okay, we're okay with that? Here's the good news. No, I know. No, I'm really not. Like, it's like you get it, but don't get it right now, right? Sometimes we're at that point, like, okay, I heard what you said. I think I get it, but I'm not super comfortable with it. That's okay. It gets better with time, and we'll revisit it. We talk about this in AP Math. We talk about dipping you. I know that sounds weird, but I don't know if y'all have ever seen those candles. I'm not baptizing you, but they can make candles that, you take the candle and you like dip it in the colored wax and you let it dry like just for a few seconds, and you dip it in a different color, and then they'll like carve it and you can see the different layers. Have you ever seen candles like that? So we talk about like layering you. So we've dipped you. I've explained it to you, right? And so then when we revisit it again and we talk about it again, you're like dipped again. And the more you get dipped in that stuff, like the better it makes it. That's why sometimes we just introduce something to you and then you do more with it next year, because then it's not brand new material, right? When it's brand new, it seems a little weird, but we'll get you there, okay? All right, we're going to skip example 3. I have to show you one of those candles so you don't think I'm crazy, but it makes sense if you know what I'm talking about. We're going to skip example 3. We're going to go to example 5. Oh, it's really not all that bad. We just don't need to do every single one of them. All right, so let's look at example 5. This here is a cubic, so what's my domain? All real numbers. This here is a cube root, so what's my domain? All real numbers. That's great news, right? Because if they're both all real numbers, it's all real numbers, and we don't have to do any crazy domain stuff, right? Okay, so f of g of x. So f of g of x is equal to f of, and then g of x is the cube root of x plus 4. So I'm going to take the cube root of x plus 4 and I substitute it right here everywhere I see an x. So I get the cube root of x plus 4 cubed minus 1. Yes? So that looks pretty bad, right? But it's not, because it cancels out. Yeah, the cube root of x plus 4 cubed is just what? X plus 4, right? Because those are inverses of each other. So I just get x plus 4 minus 1, which means f of g of x is what? X plus 3. Everybody okay with that? Any questions? The domain, because the other stuff is the review. The domain is the new stuff, and it is a little, it's a little tricky on your brain, I know. And it's not just because it's new, it's because it's a little bit confusing to talk your way through it every time. But the domain here then is all real numbers. But let's talk through, well, no, I guess because they're both all real numbers, it wouldn't do any good. So let's do now g of f of x. So this is g of, and then f of x is x cubed minus 1. So I substitute x cubed minus 1 everywhere I see an x in g of x. So this is equal to the cube root of x cubed minus 1 plus 4. Okay. So do those parentheses really do anything right there? Nope. So that means I can simplify this to the cube root of what? X cubed plus 3, right? Because that negative 1 and that 4, and that is g of f of x. And the domain is all real numbers. Okay. Any questions about that? We good? All right, so now we are going to evaluate. So we're done with the weird domain stuff. We only had one that was like really weird, but it's not that bad. Now we're going to evaluate them. So these don't say, give me the domain. So that's a good thing. We don't have to worry about it. Don't try and figure it out if it doesn't ask you for it. We're going to evaluate. So I'm going to evaluate f of g of 3. So I want f of g of 3. Which means the first thing I have to find is g of 3, right? So I'm actually looking for f of, well, here's g. If I substituted 3 in there, that becomes 3 plus 1, right? Everybody understand where the 3 plus 1 came from? Because it's x plus 1, and I substituted the 3 in for the x. Yes? Yes? Okay. So then that gives me f of 4. Then is finding f of 4 pretty easy? I just substituted in, and it's f of 4 is the absolute value of negative 2 times 4, which gives me the absolute value of negative 8. So f of g of 3 is what? 8. Everybody okay with that? Any questions about where anything came from? Don't wait until it's too late to tell me where I lost you. Okay. I lost you? Okay. All right, so now I need g of f of negative 5. So that gives me g of, and then I substitute negative 5 in for f, absolute value of negative 2 times negative 5. So what's negative 2 times negative 5? 10. And what's the absolute value of 10? 10. So this is just the g of 10. So then I take the 10. You see how the input, my input was negative 5. This is 10 is my output of f. It becomes my input for g. So now that becomes 10 plus 1. So g of f of negative 5 equals what? 11. We good? Not that bad. Now we're going to look at some square roots. Make sure we cannot freak out when things look a little weird. This gives me f of g of 9. Okay. So that means I want f of, well, g of 9 is going to be the square root of 9 minus 4. So does that become 3 minus 2? No, you don't get to take the square root of both of them, right? I'm sure there's some glue there somewhere. Okay, but 9 minus 4 is 5, so f of the square root of 5. So then I take that square root of 5 and do what? Substitute it into the f function, right? So I substitute it in here. So this is going to give me the square root of 5 squared plus 5 times the square root of 5. Now, depending on, you know, how much you did these in Algebra 2, square roots might push you out of your comfort zone a little bit. Just because they look weird does not mean they're difficult, and you don't get to go making stuff up, right? Square root of 5 squared is what? 5. Okay, that's very important. That kind of thing comes up a lot, and I get weird stuff all the time. It's just 5. It's super easy, right? So this square root of 5 squared is just 5. And then 5 times the square root of 5 is what? Can you do it? It's 5 times the square root of 5, right? So all you can do is stick them together. So that's 5 plus 5 times the square root of 5. Does that become 10 times the square root of 5? No, it does not. You treat your square roots like variables. That's like 5 plus 5x, and it's 5 plus 5x, right? So that is it. So f of g of 9, extra parenthesis there, hang on. F of g, come on. All right, hang on. My board's thinking about catching up with me. There we go. F of g of 9 is equal to 5 plus 5 square root of 5. Ugly answers are fine, okay? Hopefully they don't freak you out too much. Everybody good? So now we're going to do g of f of 7. So that means I get g of, and I substitute the 7 in, I get 7 squared plus 5 times 7. So that's g of 49 plus 35. What's 49 plus 35? 84. So I get g of 84. So that's going to be the square root of 84 minus 4, which gives me the square root of 80. Now, is that a perfect square? No. Do I reach for my calculator here? No. The calculator's not going to help you. Do I leave it like that? No. I have to simplify it, right? Do we all know how to simplify square roots? Okay. Were you taught to do the factor tree? Okay? Were you taught to always find the biggest perfect square that divides into it? Okay, good, because there's nothing wrong with doing that, but sometimes that takes a lot longer, right? So I'm going to walk you through this just in case you need it. You may not all need it, but if I take the square root of 80, and this can be broken into 8 and 10. You could break it could be 2 and 40. It could be whatever your factors are, but 8 and 10 works. So then this is 2 and 5, right? And I'm going to circle those because those are prime numbers. Then these are 2 and 4. Now, we should be past the point where we absolutely have to go past all the way down to the end, right? So if I get to a perfect square, I can just hang out there for a second. Here's what I'm looking for. I have 2 2's. They come out as a 2. I can take the square root of 4. It comes out as 2. This guy has to stay inside, and so I get 4 square root of 5, right? Other ways to approach it, but if you have no idea what to do, maybe you can follow that. Maybe we need to practice.
At this time, please release varsity football, band student, sidekicks.
Hold up. Okay, hang on.
That are involved in the pep rally, and we will get back on here in probably about 10 minutes.
All right. So are we good with that? Yes? Go back to the factory. Okay. Why did I or why didn't I? Why did it? Because it's a perfect square, I don't have to. Like you can. I can. And so this does become 2 and 2 here. I can do that. And then I get the same thing because that's where this 2 came from. Since it's a perfect square. Because like if I got to 16, and I know 16 is a perfect square, and that's just going to pull a 4 out, right? Otherwise, I get a bunch of 2's, which it just kind of saves you that. But you may not feel comfortable doing that, and that's okay. If you want to take it all the way down to get all of them, there's absolutely nothing wrong with that. I'm not saying you have to cut corners on that, because it's better for you to do the whole tree and get it right than to try and take shortcuts and get it wrong. And sometimes just doing the whole tree out, you'll be done faster than the person that's trying to find the biggest perfect square, because they're having to do so much just guess and check. Okay? Any other questions on that? Okay. But these are we need to be able to simplify our square roots. I know that that's something you've done. You may not feel super comfortable with it, but maybe we need to practice a little bit. Okay. All right, we good? Okay, so now we're going to decompose a function. And this is not nearly as complicated as it sounds or looks. It's really not that bad. I am positive. So it says find 2 functions f and g such that f of g of x equals h of x. We're going backwards. Instead of putting 2 together, we're taking 1 and we're going to take it apart. And there's actually more than one right answer on some of these, and that's fine. Okay? So let's look at this. The easiest way to do this is to work from the inside out. What we want is we want h of x to equal f of g of x, right? Hey, oh, come on in. You're going to have to listen to me for a few minutes. All right, so f of g of x, right? So my input becomes g of x, right? Okay, yes, you can have there's more than one right answer to these, all right? It's okay, and it's fine if she didn't say that, but you want to make sure you know that, because sometimes, you and your friend are working together on something, and you're like, this is the right answer. Like, no, this is the right answer. And then you get this fight, but you're both right. Like, you need to get over yourself. Yes?
So does this mean, like, if I have a test on this, I can't fail it?
Oh, no, I didn't say there's unlimited right answers. I said there's more than one, not an infinite amount of right answers. Okay. All right, so h of x is equal to f of g of x. G of x is my input. So we can work from the inside out. I'm going to find g of x that'll work and an f of x that'll work. So if I work from the inside out, if I use this part, 1 minus 2x as my g of x, as my input, then what do you think f of x would have to be? X cubed. Okay, so let's see if that makes sense and then see how easy this really is. Because if I take this and substitute it in here for x, isn't this what I get out? And that's what I'm trying to do, right? Now, this is not the only answer that works. We could say that g of x instead is 2x. And if g of x is 2x, what would f of x be? 1 minus x. Oops, cubed, right? So one's not better than the other. They're different because you weren't really given guidance on what you have to have. Does that make sense to you? All right. So let's look at 9. So I'm going to look for a g of x and an h of x. Not an h, I'm sorry, an f of x. So the easiest thing, I think, is, to kind of look at it holistically. My board is being ridiculous. So my input, if I just take the whole inside here, and I can have x squared plus 1. If that's my g of x, then what's f of x? The cube root of x. Yes? Okay. Or my g of x and f of x, what could I have instead? What could my g of x be? Well, it's still got to work from, it's still got to be something on the inside, like the input part of it. What if it's, well, this is going to have to be a cube root, but yes, that would be my f of x. If I did the cube root of x plus 1 here, what would my g of x have to be? X squared. Does that make sense? You just take part of it. And so if this is my input, x squared, this is what my other part could be. We good with that? And it doesn't matter. It's however you see it. Okay. So I want you to think about this one for a second. Let's look at g of x and f of x. So y'all give me a g of x. What do you think g of x could be? Anybody? So inside out. Huh? X plus 7? X plus 7 be a g of x? Look, I'm going to take just this part. If this is x plus 7, then what would this have to be? 4 over x and then minus 1. Yes. All right, so we got another option. Or what if my g of x was 4 over x plus 7? If that's my g of x, what's f of x? Close. Just x. This whole thing would substitute in for the x, so it would just be x minus 1. You see how we just take that and replace that x? And then I can use that one. Okay? We good with that? All right, last one. I think we got more than just more than 2 options here. All right, so g of x. Oh, come on, board. G of x and f of x. So the easiest way, I'm not going to make you come up with all 3 if there's 3. I just want you to see that there's more than one answer sometimes. We work from the inside out. So if I just take this input, that could be my g of x, right? X plus 5. If that's the case, then I could have f of x would be what? Negative 1/2 times the absolute value of x plus 3. Okay, see? That's what it takes sometimes. I was dipping you, like I said. Now you get it. That's what I'm looking for, is that oh moment. You see what I mean by work from the inside out now? Okay, good. All right, so instead, what could be a different g of x? Any ideas? Could I take this whole first term and make that negative 1/2 times the absolute value of x plus 5? If that's my g of x, could I do that? If I did that, then f of x would have to be what? X plus 3. You see how you're just breaking it up differently? We got one more for you. Or what if g of x was the absolute value of x plus 5? Then f of x would have to be what? Negative 1/2 x. Would I have to put an absolute value here? No, because this takes the x part, right? And then I have to do plus 3. Okay? So sometimes our brains work differently than other people's, and that's fine. And those are all perfectly fine answers, just different ways to look at it. Are we good? Any questions at all? Awesome.